solve quadratics today. So quadratic equation, and I failed at typing that apparently, standard form of a quadratic equation should be ax squared plus bx plus c, forgive me, equals 0. If to make an equation, I gotta have an equal sign, fired. Okay, so that should say ax squared plus bx plus c equals 0, my fault. And the main difference between what we've been doing the last couple of days and what we're gonna do today is we will have an equal sign and it will be equal to 0. That's what we wanna do. All right, now, this is gonna not really look super similar to the questions, but this is what we're gonna be using today. It's called the zero product property. So this just says if P times Q, and P could represent any number, Q could represent any number. If P times Q equals 0, then either P has to be 0 or Q has to be 0 to make that true. So if I multiply two things together and the answer is 0, one or the other has to be actually equal to 0. That's what we're going to actually use in these first couple of questions here. Okay, now what a 0 is, you guys did this when we did our graphing. So I'm going to write two things here. On a graph, if you graphed a quadratic, it's just where the graph crosses the x-axis. And we used that in our last unit. So on a graph, it's just where the graph crosses the x-axis. That's your 0. Now, what we're going to work on today is algebraically, if I can spell, it's x value, and I'm going to write, it could be more than 1. And most of these questions it is. It's usually 2. So it's the x value or values that make your equation equal 0. So if we plug this number in, it would wipe everything out in the whole equation. So x value that's going to make your equation equal to 0. That's what we're going to work on today because we've already done the graphing. So we're going to do the algebra. All right, now, like I said, I know this doesn't look identical to what I just wrote, P times Q equals 0, but really what you have here, you have a set of parentheses, so something here, times another set of parentheses, and it's equal to 0. This is a quadratic that's just already been factored, and so if I multiplied this back out, we don't want to do that. We actually want it in this form to actually find the answers, because you can see them real quick in this form. Basically, either this set of parentheses, the x minus 5, if that was equal to 0, and we plug that number in, it would wipe out the whole thing, or if what's right next to it, the x plus 3, if that was equal to 0, that would also give me another possible answer. So you don't have to write these equations out. I kind of just do these in my head a little bit, but you're basically trying to tell me what would you plug in for x to make that 0, or if you want to solve the little equation like this one, I would just add 5. So one answer is 5. Here, if I had x plus 3, if that was equal to 0, in that case, I'd subtract 3. So my two answers to that question, if I plugged in 5, we'd have this side would be equal to 0. If we plugged in -3 for both of these x's, it would be equal to 0. All right, now, if you've got something a little bit more complicated, so like I've got these two things multiplied together to give me 0. So either the first one, which is 3x minus 2, that needs to be equal to 0, or the second one, the 2x plus 5, that needs to be equal to 0. Now, if you've got a number in front of the x, like I do in both of those, your answer is just going to be a fraction. And it shouldn't be anything that you'd have to reduce, but you're going to do just 2 steps. So if I do 3x minus 2, I'm going to add 2, and I'm going to divide by 3. And just go ahead and leave it as a fraction. So 2/3. If I plugged in 2/3, and you can check these on your calculator if you want, but if I plug in 2/3 for both of these x values, it would make this first set of parentheses 0, but that would wipe the whole thing out. If one of those sets of parentheses is 0, it makes the equation true. For this one, and I'll just kind of tell you, I don't usually write it out. This is what I just do like in my head, just if you guys want to use this. I literally just go, okay, what would you do? And I just say to myself, okay, I would subtract 5 and I would divide by 2 if I was solving that equation. So I don't actually usually go through and write it out. You can if you want to, or you can, if you want to just kind of do it in your head, just think what steps would I take. Like for this one, I would have said to myself, okay, I'd add 2, so the 2 would go on the top, and I would divide by 3, so the 3 would go on the bottom. So if you want to write it out, you can. If you don't have to. Now, this last one right here, this is really tricky. I have two things multiplied together to give me 0, right? One of them's not in parentheses though. So I just have a 4x. If we were looking at this problem and we had factored it, this would be a situation where we just had a greatest common factor, and that greatest common factor would have been the 4x. But I still do have two things multiplied together to give me 0. So either 4x would be 0 or x plus 1 would be 0. Does anybody know if I just have 4x equals 0, what would x have to be to make that true? 0. Okay, and I don't know why. The only reason, and if you actually go through and do this, if you divide by 4, x would just be 0. The only reason I'm pointing that out, I just think when there's a number in front like that, some people just automatically go, oh, it's 4. But if I plugged in 4 there, 4 times 4 is not 0, it's 16. So just be careful. If you have an x out in front of some parentheses like that, whatever the number is in front of it doesn't matter. If x was 0, that would get rid of that entire equation. My other answer there, I have x plus 1, so it's just going to be the opposite, which would just be -1. And you see all these questions had 2 answers to them. Is anybody having a question? Okay, now, most of these problems are not going to be given to you in factored form. You're going to put them in factored form. That's why we've been practicing that the last couple of lessons. So this says we're going to solve these quadratic equations, solve each of the following equations by factoring. I just want to make a note. All right, there's 2 things you want to do if you have a quadratic equation that's just everything's multiplied out. I don't have any parentheses. First thing you want to do, set the equation equal to 0. And the second little note I'm going to make is you want I'm going to write ax squared. It could have a number in front. It might just be a plain x squared. You want that term to be positive. So if you have a negative or a negative number in front of your x squared term, we want to move that to the other side of the equation to make that positive. Anytime you want to apply any of the factoring that we've been talking about, the x squared term needs to be positive, not have a negative number in front of it. Okay, so I'm just going to practice this. So my very first question, first thing I want to do is set this equal to 0. So to do that, my x squared term's already positive, so I want to leave that where it's at. All I would do there is just subtract 18. All right, so I'd have x squared plus 7x. To move that 18, it was positive, so I have to subtract it to move it to the other side, and then I am set equal to 0. All right. Now, here's what I got to do. I'm going to try and write my 2 factors. Both of these sets of parentheses are just going to start with the plain x, because x times x will give you back that x squared that you got there. And you don't have to write this out, but I'm going to write this on my paper. I want to multiply. First times last would just be 1 times -18. So I want to multiply to get -18 and add to get 7. Can you think of 2 numbers, if you'd multiply them together, they'd give you -18?
Positive 9, -2.
Okay, perfect. Now, positive 9, -2. The whole reason I'm doing this, let me back up. I should have said this to you before. The whole reason I'm doing this, you can't actually solve that equation as it's presented to you, right? Because you can't put x squared and x together. So that's why we're doing factoring, because I can solve these 2 little equations using that 0 product property, but you can't just solve this equation without doing something to it. So factoring is one of the options for solving. You can't always factor a quadratic, but everything we're going to work on today, you can. Now, the main difference between this and just factoring, you got to tell me the 2 answers. So what would my 2 actual answers be after I've got that factored form? We've got x plus 9 times x minus 2. So 2 things multiplied together give me 0. Either the first one has to be 0 or the second one has to be 0. So what 2 answers am I going to have looking at that factored form? Yep, -9, +2. Done. Okay, question next to this just has 2 terms. So if it just has 2 terms and they both have an x, you cannot just get rid of an x. You can't like divide both sides by x. So what I want to do, I want to just do a greatest common factor like we did right before the break. So it literally looks like undoing a distributive property. So I'm going to pull an x out in front, and then left over, if I do that, I would have x minus 5. And I'm creating a situation. I can use that 0 product property now, right? I've got something out here, 1, two things multiplied together. So what would your two answers be for this question? What do we think? Yeah. 5 is one of the answers, not -1 though. What do you think? 0. It's really tricky. If you just have a plain X out in front, if I plugged in 0, do you guys see in the original problem? Like if we put in 0, right? Bless you. 0 squared wipes that out. 5 times 0 wipes that out. So 0 if you have just a plain X, or if it has a number in front of it. But that answer is just going to mean one of the answers to the question is actually 0. All right, we're going to keep our squared term positive. So on this last one, I want to set this equal to 0. So I'm going to subtract the 21x. Okay, now, you cannot do this with variables. You cannot divide by x. You can pull it out in front. You cannot divide both sides by x. But if the two terms have a number in common, you can actually just get rid of it. Do 3x squared and 21x have any number that they're both divisible by? Bless you. 3. Okay, now, if we're factoring, we'd have to pull the 3 out in front. If you're solving an equation, though, it has to be a number. You can't do this with variables, but you can do this with plain numbers. You can get rid of the 3. You are allowed to divide 0 by number, totally legal. It's always 0, but then this just becomes x squared minus 7x, and then equals 0. If you've got a number, greatest common factor, that's just a plain number, you can get rid of it, just divide everything on both sides, and it makes the coefficients you're working with smaller. This is almost then identical to the question we just did, yeah.
Why couldn't we divide by 2x?
You can't divide by x because 0, you have to know what the variable is. You can divide 0 by a number, but if you don't know what the variable is, you can't divide by that. Does that make sense?
Yeah.
You can pull it out in front. So I'm going to take and write this as x minus 7. So you cannot do that with a variable. You can't divide both sides by x. All right, but I can divide by a number because 0 is always divisible by a number. Now, my two answers, like I said, super similar to the question we just did. This is 0. This one would be positive 7. So those two questions, just a greatest common factor. I just had two terms, pulled the x out in front, got rid of any common numbers, and we were good to go. All right, now the next one, I put a little tiny graph next to this, and I want to explain that to you here in a second. But I'm going to set this equal to 0, and my squared term's already positive x squared, so what I'm going to do that, I'm going to add that 16 to the other side. Can you guys, this is back to kind of the factoring where we've got 3 terms here. This is a trinomial, 3 terms. So for this one, where's my pen? I want to multiply to get 16, and I want to add to get negative 8. Can you guys think of the numbers that if you multiply them together, you get positive 16, add them, you get negative 8? Yes, okay. Now, I can, right? We could squish these guys together, right, at x minus 4 squared. What's my answer here? Does anybody know? Yeah, it's just 4. So 4 would actually, like for both of those little factors, they're exactly the same. You only have one answer. All these other questions we've been working on have had 2 answers. The actual answers is where the graph would cross the x-axis if you had the graph. Okay, what I'm going to do just real quick on this little tiny graph, and sorry, I should have made it a little bit bigger. I just want to show you what this looks like graphically. So I'm going to graph the related quadratic. To do that, I'm just going to graph y equals, instead of putting it equal to 0, I'm going to write y equals that x minus 4 squared. Because basically what we did when we factored that, we put that in vertex form real quick. So we'll throw back to our last unit. My a value would be 1, so my pattern would be the 1, 3, 5. And my vertex, I'm just going to do opposite copy here. So for this question, it would be positive 4 and 0. And you can see that was my answer, right? Positive 4 made it equal to 0. If you come over to the graph, sorry, it's super tiny. 4 zeros kind of like right there, kind of close to the middle. I'm just going to go over 1, up 1, over 1, up 3. And that'll give me a good idea of the shape. What I want to point out to you, if you only have one answer, like we did here, the answer was just 4. The reason for that is it's actually going to be a situation where the vertex is the only point on the parabola that touches the graph. So it's totally possible for you to get two answers, possible for you to get one answer. If you get one answer, this is what it would look like on the graph. That value would just be the x-coordinate of the vertex, and it's going to be on the x-axis. So it just would touch in one spot. That's why I only have one answer for that question. Okay, now I've got one more. Before I start this problem, you guys, I got 3, 24, 27. Do all those numbers have anything in common? What number? 3. Okay, so totally legal. Get rid of a number. If they all have a number in common, get rid of it. And I'm going to do that, just divide every single thing. And now, if they're not all divisible by 3, you can't get rid of it, but they are. All of these are divisible by 3. This is going to give me x squared minus 8x minus 9. And 0 divided by any number is 0. To factor this guy, all right, I'm going to start both of the factors, just a plain x, so x times x will give me back that x squared. All right, so for this one, I got to multiply to get negative 9 and add to get negative 8 to get my factors set up here. Can you think of two numbers? I'm going to multiply them together, get negative 9, add them and get negative 8? Yes, okay. So one's a minus 9, one's a plus 1. Multiply those together, give you negative 9. Add them together, though, you get negative 8. What are my actual answers to the question? What are my actual zeros there? If you're in that factored form, just tell me what would you plug in for x to make that 0? Negative 1, this one would be 9, this would be negative 1. It's just what you would plug in to make that 0. Is anybody having a question? Now, oh, shoot, sorry guys. Sorry. I'm going to ask the 2 questions at the top here. We're going to use the Mary method. And, or if you want to use a different method that you like better, that's totally fine. I'm going to use the Mary method of test here this morning. So practice that from yesterday. And if you guys want to look at that while I'm plugging this in, sorry. So these 2 at the top are both going to be a situation. We don't have a greatest common factor between all the terms, but what I do want to do, make sure you set these equal to 0 first. So you want your squared term to be positive. In that question, I've already got it starting out with positive 3x squared. So what I want to do, I'm going to move the 20. It's positive, so when I move it to the other side to set it equal to 0, we're going to subtract. Okay. Now, I know we've been mixing these together today, and we haven't done that before, but this does have a number in front of the x squared. So when I set up my factors, please, 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 don't forget that first term, whatever that is, this one's 3x squared. You write that, but drop the squared. So I'm going to copy a 3x at the beginning of each of the factors. This will be an extra step the other questions on the front didn't have, because we didn't have a greatest common factor between any of the terms in the parentheses, but we will here. Now, I'm going to write this just hopefully so you guys remember it, but if you remember it, don't write it. You're going to multiply a times c, first times last. The a value would be 3, the c value would be negative 20. So if I multiply those 2 together, that's negative 60. And I'm going to add to get the b value, which is just the one attached to the x, so that's negative 11. All right, now I always think this one's super tricky because 60 has a bunch of factors. So I'm just going to write down some factors of 60 here. So if I get stuck, that way I can kind of pick from the list. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 6 and 10. So I have a ton of different options, lots of multiples of 60, or lots of factors of 60. What combination can you get to multiply up to get you negative 60 and add to get you negative 11? One of them's going to have to be positive, one of them's going to have to be negative. What do you think? Yes, okay, we're going to use the 15 and 4. To get the negative 11, we got to use negative 15 and positive 4. That'll multiply to get you negative 60, negative 15 plus 4 is the negative 11. Okay, now, remember, If I FOILed this back out, it would not give me what I have right above there. So you're looking for, do I have a greatest common factor between any of the terms? If I do, it's not the real factor. So for this one, that first one I wrote down, 3x minus 15, those are both divisible by 3. So the real factor there, this would be x minus 5. 3x and 4 don't have anything in common. So be 3x plus 4 is going to stay the same. And again, if you want to check just real quick, if you multiply the first two terms together, that should give you the first term that you have in your quadratic. So I'm just checking this real quick to make sure I got my factors right. X times 3x, give me 3x squared, we should be good. And if you want to check, the last two numbers should give you the plain number in the quadratic. So negative 5 times 4, that's negative 20. So we should have our factors correct. My actual answers to the question, like right here, x minus 5 is just what sets that equal to 0, be positive 5. Now, if you got a number in front, right, I've got 3x plus 4. If I set that equal to 0, here's literally what I do in my head. I just think about that. Like, what would I do to get x alone there if I set that equal to 0? I think, okay, I would subtract 4, and then I would have to divide by 3. So negative 4/3 would be the other answer for that question. And if you've done it right, if you do get an answer that's a fraction, you shouldn't need to reduce it or anything. It should just already be reduced. Let's try one more with this Berry method because I know these are harder. All right, so first thing first, set equal to 0. So to do that, I'm going to add the x. My x squared term was already positive there, so I don't want to move that. What I'm going to do when I add the x, I'm going to put that in between the other two terms so it's in standard form. So I'm going to write 2x squared plus x minus 28 equals 0. All right, we don't have a greatest common factor here, so I can't get rid of the 2 or anything like that. So this is going to be Berry method, hopefully, if you like that, or if you like a different method, that's fine too. But my first step here, these are not going to be the real factors. One or both of these are going to be wrong. What I want to do is find two numbers. You're going to multiply the first times the last. So 2 times negative 28 is negative 56. And then add to the middle. The middle ends up just being positive x. So what's my b value? If it's just an x, it's 1. Good. Can you guys think of two numbers, if you'd multiply them together, they'd give you negative 56, but if you added them together, you'd get 1? And let me think, hold on. If I'm not sure, it'd be 1 and 56, 2 and 28. I think it's divisible by 4, yep, 4 and 14. 7 and 8, I think those are all my possible combinations. What combination can I use to add up to 1? Colton, what do you think? Sweet, okay. Only way you can do it. Positive 8, negative 7. Only one of those options will work. There's only one set of numbers that will fit both of those requirements. Okay, now, remember, this does not FOIL back to give me what I have right above there. 2x plus 8, those are both divisible by 2, so that's not the real factor. Just reduce it. That real factor would be x plus 4. 2x and 7 don't have anything in common, so that 2x minus 7, that would be the real factor. And again, I'm just going to show you this. You don't have to, but I do it just to check. The first two multiplied together should give you the first term. So x times 2x, that's 2x squared. We're good to go there. And if I want to check the last two, should give you the plain constant in the original problem. So 4 times negative 7 is negative 28, so we're good there. Those are my factors. Answers to my question are negative 4, and then for the 2x minus 7, okay, just if you want to write it down, write 2x minus 7 equals 0. If you want to do it like that and write it out, if that's 0, that'll make the whole thing 0. If I do it, I just kind of think about it in my head. I'm like, okay, how would I solve that equation? Well, I would end up adding 7 and dividing by 2. So then my other answer there is going to be 7 over 2. Anybody having a question? Okay, now, I just put this little chart together here real quick to show you guys the standard form and factored form of the same equation. So this one, I'm just gonna factor this super quick for you. Multiply to get negative 14, add to get negative 5. My two factors there would be x minus 7 and x plus 2. And you can write those in any order, doesn't matter. What I was going to say too, though, the standard form and the factored form, that's the same quadratic. If I type this like into Desmos and I type the factored form into Desmos, it would give me the exact same parabola. So it's just two different formats. If it's in standard form, you can't just solve it in standard form because we can't combine like terms. But if I can get it in factored form, I can figure out the two values that are going to make this true. So for this question, the zeros would be positive 7 and negative 2. If you wanted to plug in positive 7 to this x squared minus 5x minus 14, it would equal 0. If you wanted to plug in negative 2, here, it would equal 0. You can plug it into the factored form or the standard form to check, but those both represent the same quadratic. And I was going to have you guys multiply these out, but I went ahead and just did it. So if you know the factored form, to get the standard form, all you would have to do is do like a FOIL or a box to just multiply that out and get the standard form. So those are the two related here, 2x squared minus x minus 28, and then the factored form to the side there. Now, actual answers for that question, negative 7 over 2, right? Here I would subtract 7, divide by 2. Here I would just add 4, so the other 0 is positive 4. And we're just going to kind of flip the script in this last example real quick. So this says, could you write me the factored form of the equation if I gave you the answers? All right, so that's what this is going to say. So we're going to write the factored form of this quadratic equation. So I'm going to set it equal to 0. If I told you the answer, or the 0 was 2, what would the little set of parentheses be that would go with that? If 2 is the answer, what would it be, x plus 2 or x minus 2? Minus, right? And so x, it's going to be the opposite of what it looks like, right? If the 0 is positive, it looks like a minus in the factor. So to solve that, I plug in 2, that makes that 0. What would the little parenthesis be if it was negative 1 is my answer? X plus 1, yeah. So that's all I would have to do, right? If I have the answers, I'm like working backwards is all I'm doing. Now, if 0 is one of my answers, so the next question says the zeros are 0 and 5. If 0 is one of the answers, one of the zeros, just represent that with just an x. That's all you have to do. So the 0 would go with that. And if it's positive 5, it would be the factor that would go with that would be x minus 5. Okay. If I've got 4 as an answer, what would the factor look like? If 4 is my answer, x minus 4. Okay, now the other one's super tricky, I think, because it's a fraction. So kind of try and think in your mind and work backwards. If you got negative 3 over 2 as your answer, what would that look like in the little set of parentheses? Anybody know? So if I set this equal to 0, I would get negative 3 over 2. Tell me. Yes, it's 2x plus 3. So if you're like, what the heck, where did we get that? First of all, first thing to check, if this is a negative 0, it should be a plus in the factor. If it's positive, it should be negative. So when you're working backwards with this, whatever's in the denominator, you're going to multiply that number by x. So to solve this, I had to subtract 3 and divide by 2 once I see that. So whatever's in the denominator, if you have a fraction, that's going to be multiplied by x. And then whatever is in the numerator, in this question it gets added because it's a negative here, but that would be either added or subtracted from what you have attached to the x. So try this one. All right, if 2/5 is my answer, what would the little factor be if I had 2/5 as my answer? Yes, ma'am. 5x minus 2. To solve that, I'd have to add 2. That would give me the positive, divide by 5. Perfect. Perfect, perfect. Now, if I'm just a negative 3, just x plus 3. All right, now, the very last question. This is just super quick. So this says, how would you write part C, so this that we just did, in standard form? So I'm just going to copy this real quick. So we have x minus 4 2x plus 3. How would I write that in standard form? Like, what would you do to get that in standard form? So I'd have no parentheses if I'm in standard form. So if I knew the factored form, how could I do that? Yeah. Okay, if you have factored form, if you need standard form, just FOIL, or if you, bless you, if you like the box, whichever way, you're just gonna multiply this out real quick. So if I want this in standard form, just multiply it out. So I'd get like 2x squared plus 3x minus 8x minus 12. This would be set equal to 0. And then a lot of times this will have a little extra step because you'll be able to combine some like terms, which I can do here. So my x's, I've got 3x's minus 8x's, so that'd be minus 5x. So then same thing in standard form is going to be that. Is anybody having a question? Okay, the homework, no, there's nothing on Delta Math. It is completely on the paper today.